Howdy folks, and welcome back. We're up to question number 19 on the 2001 Pascal paper. So that's the grade 9 paper, the multiple choice one put out by the University of Waterloo. They do have a written contest nowadays for grade 9 called the Hypatia. So question 19 says, two circles with equal radii are enclosed by a rectangle as shown. The distance between their centers is 2/3 x. The value of x is, okay, so we have a rectangle here, side length 10 and x, and we know the distance between these centers and that these are circles with equal radii, okay? So, let's draw our picture, and we're going to mark it up with some mathematical workings, and we'll see what we can do. You know what? I should probably draw the circles first. And so there's some overlap according to the picture. We'll put their centers in here, and now we can try and draw a rectangle around them. Doesn't have to be exact. Your pictures never have to be exact. As long as you know what's going on in them, that's all that matters. Like I said, this is the multiple choice contest, not the written style contest. So no one's going to be taking a look at your rough work or any of the pictures you draw. Alright. So we have an overall length of 10 here, and then we have x as the other side length, and we're trying to find the value of x. And one of the things we're told is that this length here is 2/3 x. Okay. Well, it'd be really nice if these circles weren't overlapping, because we could just, if they were just touching one another, we'd have the radius. And we know that the radii are equal. 2 radii would be 2/3 x, and we could probably work it all out, but we don't quite have that. But adding in this radius has made me think, well, I could add in a radius here and a radius here. And together they're going to form a diameter of the circle. But since it touches both sides of the rectangle, I know that the diameter, x, is the diameter of the circle. So the radius is just going to be x over 2. Well, how does that help us? It doesn't help us in the center here, but we can add in this radius here and this radius here. So 10 is equal to this radius, plus the 2/3 x we have in the middle, connecting up the centers, plus another radius at the end. And we know the radius in terms of x. So x over 2 plus 2/3 x plus another x over 2. And we can start to clean this up. X over 2 plus x over 2, that's just x. Plus 2x over 3, well, we can write x as 3x over 3 and get that common denominator of 3 going. And we'll be left with 5x over 3. So now we know 10 is equal to 5x over 3. So if I want to get x by itself, well, I did 5x divided by 3. The last thing I did was divide by 3. So the first thing I'm going to want to do is get rid of that by multiplying by 3. So 30 is equal to 5x. So when I say that out loud, I say 5x. The last thing I did is multiply it by 5. So I'm going to want to divide both sides by 5 to just get x by itself. And we get 6 is equal to x. Okay? So 6 is equal to x. That means that 6 is the diameter of these circles. So 3 should be the radius. So 3 plus something is equal to 10. So this something in here, this 2x over 3 should be equal to 4. And wouldn't you know it, 2 times 6 is 12, divided by 3 is equal to 4. So we just did a little mental arithmetic, a mental check of our answer. I'm really confident in it. So let's see if it's one of the solutions. There it is. It's C over here on the side. So we'll bubble in C, and we'll move right along. Okay. So we have just one more question remaining in Part B, and that is question number 20. We're going to take a look at that in the next video, and then we'll move on to the last 5 questions in Part C, where each answer is worth a little bit more, and each question takes a little bit longer. So that's all for now. I'll see you guys next time.